This meeting is being recorded.
Hello, good evening team, and good evening professor and TA. We belongs to study group 10. As part of our group presentation, we are gathered here to give a presentation about advanced artificial intelligence subject. Those like we are the team of 3 people. Okay, the main agenda of the topic is that here we are going to we have gone through all the papers which was shared by Professor David Dye. The papers are mainly concentrated on brief history of artificial intelligence and the machine learning in Python and bench marking contemporary deep learning algorithms. Next. I would like to present the brief history of artificial intelligence. Next. Here, what is artificial intelligence? It's been like, as we know that where the artificial intelligence is right now, but at the beginning times, it is very hard to at least to have the idea, at least to get the idea, like to have a machine to think. Initially, John McCarthy created the term artificial intelligence in 1956. He proposed that he has a thinking that human can think, or else he proposed that people's own understanding and knowledge. And after that, Alan Turing, he's almost the founder. He thinks that whether the machine has the ability to mimic human behavior and perform intelligence tasks like the human do, such as playing chess or doing some activities what the humans do on daily basis. And AI employed in more subtle ways, such as evaluating purchase histories and influencing market decisions rather than taking machines used to steer spaceships to Jupiter. Next. Alan Turing has proposed a basic a test called Turing test to check whether the machines can think or not. He has a game, idea to have a game which has a man, a woman, and an interrogator. The main theme of the idea is to get to test the machine whether the machine is finding or is it identifying that whether who is speaking with the machine, whether it is male or female. Next. But the problems and difficulties in the initial stages of the Turing test are the storage limitations, because that time, in the initial time, we don't have that much of luxury to store large volumes of data. And he found that God has the immoral power to give the thinking power to the humans, but not for the machines. And for his proposal, he has got some counter arguments that is imitating, whether he is proposing a machine that imitates the human, is it enough? And the thing is that whether the machines can do on their own. But overall, the potential problems fall into 2 categories, like imitating a person proves intelligence, or else the intelligence possible with the Turing test. If it passed the Turing test, we can't say that it is intelligent. Next. At that time, few of the other researchers have proposed alternatives. One of the researcher, Friedman, Test, and Nicholas Negogans, they have proposed 2 different approaches for the Turing test. They found that it is very difficult in some areas because of the expert problem solving, but easier in other because of the casual conversation isn't required. Nicholas has some test proposal, but it was more challenging since the computers need to be able to interpret inaccuracy and person communicated. Next. The current Turing test status is that till now no machine has solved the problem of Turing test, but researchers are getting better to get the best solution out of it. But the as of today, we got faster computers, and we got the like we have hard disks to store large volumes of data. But till now, we couldn't able to find the solution for the Turing test. But researchers are going on to find the exact solution for the problem. Next. History of AI applied to the chess. Initially, uh, Shannon has published a paper developing a chess playing program. He has proposed two different approaches to solve the uh, problem. Like he has a type A program and type A program. Like, but initially all the researchers went into type B program over type A because they don't have they have some restrictions about the computing power and all. But after that, they went back to type A because it is very easy to develop and implement. Next. After that, like in the advancement of AI, we have got an expert system aiming to replicate human model based on knowledge database. That means human knowledge and experience is the most thing, because human have evolved and developed his skills from the childhood by his experiences and the knowledge which he got. And the input output interface, that is the interaction of the user from the system. The following are the characteristics of expert system. Rather than relying solely on numerical competence, use symbolic reasoning. The processing is based on the data only. The database of specified contents for a certain area of knowledge, the ability to interpret the result in a user-friendly manner. These are the main features of the expert system which was developed. Next. The expert system has some applications like chemical structure analyzer and medical diagnosis system, and oil mineral processing, genetic engineering, and automation, automobile and processing, and air traffic control. Next. The key technical issues with the proposed expert system is that the software compatibility and standards, because that time there are no standards to show that the system is perfect or not, and knowledge gathering and analysis. To gather that much of vast knowledge, it was difficult in those days. And handling uncertain situations. System integration, that means to integrate the system with the other systems, it was more cost effective that time. And validation is also the issue with having the new technical system which was developed. Next. Instead of having technical and technical issues, we have encountered some managerial and organizational challenges for that expert system. Alignment of technology and business strategy and maintenance cost of expert systems. Expert systems do make mistakes, and resistance from users, because those days no one was willing to take the to implement the new systems, new artificial intelligence systems into their processing units or else in their business, because they don't know how the system or machine performs on its own. It was not proven those days. That's why they were users were resistant to implement these systems. Next. Is thinking machine ever possible? Overall, yes, the researchers are going on, and the limitations to have a thinking machine is that humans know how and what they are doing, but not the machines. They do work on the instructions given by human only. The human mind and structure, and the thinking power is different. It's natural, but not the machines. Machines work on programs and the logics. And the social implementations for expert system. The social implementation for expert system reflects that if a business user implements a automatic like AI machine into his business, video like for example, for a defense project, if he implements AI, he don't know if machine do something which is not natural. That means it is a business loss for his. That's why it is having a limitation in this aspect. Next. AI winter and its lessons. AI winter session is that it is the drop, like the setback period for the development of research in AI field. It was triggered, and that time ALPAC reported that automatic and instant translation of, like, they have said that uh, they have developed a machine. That time it translated the Russian language into English, which was used in the used to have to get the uh, confidential data from the other countries. And Lighthill report projected that projected the past disappointments of the proposed translation systems, but they found that it is like they are investing on the wrong thing, and they revealed the reports revealed major shortcomings in AI technology and had some fatal impact on the government financing on AI research, which was a great setback for the AI research to develop. Next. This is the to demonstrate the AI winter session. We can see that peak of inflated expectations in mid 1980s, when there was a peak in the research area, like when there was a peak while the advancements of AI field, it was suddenly dropped because of those reports. And then it's been till today, it's been just getting a small growth in terms of development. Next. And this is the attendees at the national conference. At that time, in that winter period itself, it reached to the peak. That means that time so many people interested towards the artificial intelligence, but after those reports, it got dropped drastically because they lost the faith on the development of artificial intelligence systems and all. That's why we can see the drop at 1968 year. Next. But Japan's 5th generation computer system project was developed to this is the initial step to have a better artificial intelligence system which performs on its own and it thinks like a machine, but not to solve the Turing test. It based on the knowledge information processing, which process large volumes of data to get a best solution. The progress was it was good. They have created some sequential. By using sequential programming and parallel processing, they have created a best machine which process 500,000 logical interface data per second. But those days, it was a huge achievement for the Japan's government to have a system like this. Next. After doing the experiment, after finding the 5th generation computer system, they have learned that it is difficult to maintain the large volumes of data and to have the large knowledge data to process for the machine to get the results. And it is not possible to develop programming structure based solely on logic. The main barrier of the artificial intelligence development is software, not the hardware. And these are the outcomings they found after doing that project. Next. Yeah. This is the brief history of artificial intelligence, where it was started and where it was ended. I finished my part, and Chase Sheldon will continue this. Thank you.
Hello, everyone. I'm going to go over what we learned in the second article machine learning in Python, main developments, technology trends in data science, machine learning and artificial intelligence. Authors of this article are Sebastian Raska, Joshua Patterson, and Corey Nolet. Artificial intelligence, or AI for short, is a field in computer science that looks to design programs that can do tasks that we as humans are typically not good at. This can be a complicated task since humans have complex processes for interpreting meaning and coming to conclusions, such as is the case with things like natural language. New techniques and practices have continued to emerge that take inspiration from the way the human brain processes data. This has given motivation for many programmers to expand the use of AI to automate tedious tasks that are time consuming for humans. Python has been at the forefront of scientific computing and machine learning. This is due in large part to the readability and usability of the language, which draws in large user base of engineers. Python is a great language for machine learning since it makes complex operations, such as operations on multidimensional arrays, much easier using libraries like NumPy and SciPy. These libraries utilize C and C++ for the use of parallelization to bypass threading when possible. Python's main compiler, CPython, usually does not take full advantage of all the modern computing hardware. There are optimized instruction sets such as Intel's SSE and IBM's Altivec that are being used under the BLAS and LAPACK libraries to improve matrix and vector operation efficiency. Libraries such as NumPy and SciPy continue to improve and receive significant performance boost through optimized subroutines. Classical machine learning refers to machine learning that does not include deep learning or deep neural networks. Rather, it is machine learning that is focused on structured data. This is best used in the case where data can be stored in tuples, where the training examples are in rows and the columns are the features of the data. Scikit-learn is a primary standard library for classical machine learning. It has extensive classes for data analysis and modeling and uses the fit and predict API model that provides a consistent way of analyzing data while using different modeling options. Scikit-learn also has a library called imbalance-learn that can be used to address class imbalances through 4 different techniques of resampling and cleaning data. Ensemble learning combines multiple models of machine learning into one to increase the efficiency of the algorithms. Gradient boosting uses features such as gradient descent to optimize models through iteration. This is especially useful for models that are weak learners. Gradient boosting machines have become very popular. However, they can suffer from performance issues due to this use of iteration. Many modern data problems are quite large, and this can be an issue for scikit-learn since it is not particularly designed for large data. There's the JobLib API in Scikit was created to deal with this issue by using algorithms that enable Python to use parallelization and multiprocessing. Python libraries such as Pandas, NumPy, TensorFlow, and PyTorch give users tools to automate machine learning pipelines through the entire process. This makes it significantly easier for users to create complex models in a fast manner with a limited knowledge. These end-to-end pipelines are known as automated machine learning. Automated machine learning pipelines usually still have a data preparation step. This step has been particularly automated through libraries like H2O auto machine learning that are able to infer data types. Many auto machine learning methods still require manual data type input though. Hyperparameter optimization is a main algorithmic component of AutoML. This is a step up from the exhaustive search model that uses hyperparameter configurations and cross-validation to estimate the model's performance without fully exhausting every possible configuration. Hyperparameter optimization uses algorithms that validate a model objectively by using a particular hyperparameter configuration. Newer AutoML deep learning research is focused on providing a model that composes entire deep neural network architectures. This model generation is known as neural architecture search. The goal is to have a search space that refers to all possible neural network structures and hyperparameters that can be put together or changed. Hardware and software are components that are connected together to get a level of performance out of an architecture. Software is always trying to be optimized to take full advantage of the hardware. This is a challenge that has seen some solutions when it comes to GPU performance and the use of Python. One solution to meeting this need of general purpose GPU library for machine learning is CUDA, C-U-D-A. The Python version is called PyCUDA. This library allows for deep neural networks to be run on top of GPUs, which significantly speeds up performance. For vectorized operations, NumPy's performance is limited. The Numba library allows for just-in-time completion and enables vectorized functions that can be executed on the GPU. Most of this functionality can be found in NumPy's ND array. Important libraries such as pandas and scikit-learn were built on top of ND array, which means that programs which use these libraries inherit the GPU enhancements. For classical machine learning, GPU accelerated libraries are critical. Many of the machine learning algorithms use matrix multiplication and matrix vector multiplication. These operations have a high performance cost. Some of these libraries that are designed to help with this are XGBoost and LightGBM. Classical machine learning relies on the way that features are engineered and how the data set is constructed and trained to get a good level of predictive performance. In many situations, these practices are not practical. Many real-world problems have high dimension data, and data cannot always be put in a typical tabular format. Deep learning is a method of machine learning that looks to overcome these challenges by processing data, often in a raw format, and automating the extraction of information and predictions. Some of the deep learning libraries that are available use a static flow graph. These frameworks include Caffe, Theano, TensorFlow, and others. Of these, TensorFlow is the most popular since it focuses on distributed computing and has reduced compilation times. Dynamic graph libraries are often used when a user wants to interact with computations in real time. This can often come at a high computation cost. Although TensorFlow originally was just a static graph library, it now offers support for dynamic computations. Dynamic graphs like those in TensorFlow have seen improved efficiency due to the use of just-in-time computing. This has made them even more desirable as they have now achieved a reasonable level of usability. Since machine learning is used on large amounts of data, it is important to consider privacy. Some learning models, such as deep neural networks, often memorize information about training examples. This can be a breach of user privacy if not handled correctly. To combat these potential privacy violations, Google released a privacy toolkit for TensorFlow. Fairness is another important factor of machine learning that can see human bias. This can be seen in facial prediction software that has been shown to have bias towards sex or gender in some situations. Machine learning models are not perfect and often have bias. Google has released another toolkit called fairness indicators that is used to pick out these biases. So in conclusion, machine learning has seen a lot of advancement in recent years for every aspect of its operations. Python and its libraries that boost performance, provide advanced toolkits, and end-to-end machine learning pipelines has been a major driving force in this advancement. There are still many challenges as data processing requirements continue to go up. This need for more advanced frameworks will likely continue the advancement in machine learning in the coming years. Next up is Sai Charan.
Hey guys, thank you. So I'm Nagasai Charan. I have learned third paper for this research survey. So it's benchmarking contemporary deep learning hardware and frameworks. It's a survey of quantitative metrics. The paper is by Tai Wai and Daniel Berland, which was actually published as a part of 2019 IEEE First International Conference on Cognitive Machine Learning Intelligence. This is 2019 paper. Can we go to the next slide? So this paper, the concepts is about machine learning hardwares such as GPU, FPGAs, ASICs, and the deep learning software frameworks too. Coming to the benchmarking concepts, a benchmarking concept is an approach where the frameworks and basically in this whole research survey, there are 11 metrics approach to hardware frameworks are also discussed as an evolution of these technologies in terms of their performance and in terms of benchmarking. Uh, so there was one more organization which is MLPref that also collaborates with both the industry and the academic to develop deep learning benchmarks that evaluate training and inherence on deep learning hardware devices. As a result, this survey also includes information about this MLPrefs, benchmark results, benchmark metrics, data, deep learning frameworks, and algorithmic frameworks. So author also provides a summary of 7 benchmarking concepts as well as differences in features across standard artificial intelligence devices and a quantitative comparison of deep learning hardware and frameworks. Can you go to next slide? Next, yeah. So despite of the fact that prior research publications give information on deep learning, it is difficult to locate a study that has that has discussed about quantitative benchmarks for machine learning hardware devices and deep learning software frameworks. For hardware devices and software frameworks and deep learning, researchers actually offered 11 quantitative benchmarking criteria in this study. Quantitative benchmark results are also provided for key deep learning devices as well as the comparison of 18 deep learning frameworks, which in the further study they have divided into 3 groups. Let's discuss in the next further slides. Next slide, please. Uh, so in this section of deep learning hardware, they have discussed about GPU devices, FPGA devices, ASIC devices, enhancing the hardware for performance. And they also discussed about some metrics which we'll be discussing in the next slide. So coming to the GPU devices, as written in the slides, these are specialized processors that accelerate real-time 3D graphics. To say it in other words, GPUs are equipped with an internal cache, high-speed bandwidth, and a fast parallel processing capabilities. Because matrix multiplication procedures doesn't need access to global memory, the GPU cache speeds up this whole operations. So GPUs are most often used hardware components in deep learning. Coming to the FPGA devices, because FPGAs include dynamic reconfigurable hardwares, the hardware engineers created this FPGAs using a hardware description language. They call it as an HDL, such as VHDL are very long. These are languages names. So some use cases, on the other hand, will be always feature situations that are energy intensive. FPGA devices outperform graphic processing units like GPUs, which were discussed in the previous one, in terms of performance per watt. There are ASCII ASIC devices. ASIC devices often offer great overall performance and a low energy consumption since they are created chips that are built for specific applications rather than general purpose jobs. Whereas FPGAs are performed for general purpose jobs, but ASICs are actually created only for specific performance tasks for specific applications. So enhancing this hardware performance, they actually discussed in this research survey using innovative algorithms, the newer algorithms. So despite of this very widespread of many more cores of CPUs and hyper threading and these technologies, so nevertheless, they exhibit their limitations in access to big data. The heavy processing requirements of deep learning models, for example, are due to presence of products and matrix transformations. Because of their multiple cores on chip memory, specialist chipsets like GPU, FPGAs, and ASICs outperform ordinary CPUs in terms of computational performance and latency. So there are two types of memory hierarchies they mentioned. One is off-chip memory, also known as global memory or main memory, or on-chip memory, also known as local memory or shared memory. So these two are make up to the memory hierarchy on these hardware devices. So deep learning algorithms can also take use of this high-speed shared memory after transferring data from global memory. Can we go to the next slide? So there was another topic which was discussed here, like qualitative benchmarking metrics on uh, machine learning hardware. So there are following metrics what they have mentioned. So they have did a comparison table and an explanation table of different CPU, GPUs, FPGAs, and ASICs of these all metrics, like computing performance, low latency, energy efficiency, compatibility, research costs, research risk, upgradability, scalability, chip price, UBCOM, time to market. So the CPU, FPGAs, and ASICs may be utilized in a variety of applications other than deep learning, such as cloud servers, edge devices, just to name a few. There are 11 quantitative benchmark indicators, like what I have read. Those are to be considered. So if you refer the research paper, there is a table which refers saying about these metrics and their performance in different hardware devices. Can we go to the next slide? So this mainstream deep learning frameworks, what they have picked, they have divided into these three separate things. Uh, to say something about this, engineers and scientists may use open source deep learning frameworks to design activation functions, build innovative algorithms, train large amounts of data, and deploy neural networks on a variety of hardware platforms, ranging from x x86 servers, which are usually found in mobile devices. So they have took 18 frameworks of deep learning, 18 deep learning frameworks, so which they divided into three groups, such as so based on different criteria like application support teams, development interfaces, and all, like mature, developing, and inactive, like as is shown in the slides. So I have mentioned only few framework names. There are few other in the paper too. It's like Cafe, Facebook, Cafe 2, Chainer framework, and Apache Signa, and Big Deal, and there is a Torch and Pruny too. So there are 10 frameworks in the mature framework in the mature criteria, which are available for usage in order to increase the training speed, improve scalability, performance, and lower development risk. Although the emerging frameworks are not yet widely, like emerging in the sense developing frameworks are not widely employed in the businesses or research projects. So some of these developing frameworks might also be applied in specialized domains in future. Frameworks that have been retired are essentially dormant. Can we go to the next one? Uh, so as in the abstract slide, I have said, like they also discussed about MLFREF group, which is an organization which does the machine learning benchmarking. So the benchmarking measurements, data sets, deep learning algorithms, and deep learning frameworks used in this MLPref benchmarks are all open source. So members of MLPref run deep learning algorithms on different hardware devices, and then they report the time it takes, the deep learning algorithms used, the deep learning frameworks used, the open source data sets that have been tested while evaluating this MLPref training or interface benchmarks. Time is a critical metric to consider there. So these metrics are uploaded to GitHub by this MLPref group. Can we go to the next slide? So coming to the conclusion and the future work of this research survey. So as we said, like there is a rapid advancement of deep learning technology. It is very beneficial with dimensions and techniques for measuring this deep learning hardware and software. So there are few deep learning that that have seen a significant growth in popularity in recent years, like image categorization, audio recognition, and language translation, that are all possible applications of this technology. You do need a lot of deep learning hardware and software. You decide by looking at the metrics to decide different factors like representativeness, relevancy, quality, repeatability, affordability, and scalability. So the deep learning technology, on the other hand, is always evolving. So there are many new and novel chipsets, helpful frameworks, and incentive models that are, and the large data sets are being developed, which are leading to expansion of this market and applications of deep frameworks. So authors are planning to launch a website which is named as benchmarking performance suite for collecting and updating these results from different benchmarking hardwares and frameworks. Can you go to the next slide? So coming to the conclusion of the whole presentation, we have discussed brief history of AI. In this, the first designed to create a system that could pass a Turing test, the AI is currently being used in a wide range of fields following the years of research. We have also learned about machine learning and Python. We went over many main developments and trends in data sciences and machine learning and artificial intelligence. And we have read about research paper, which is a survey of benchmarking contemporary deep learning hardwares and frameworks, which is a survey of quantitative metrics. There is a 6 metric approach to framework and 11 metric approach to hardware platforms that are used to evaluate this deep learning hardware and frameworks. Those are discussed in this paper. Thank you for your time, guys.